I created a new project called Lambda Intro for this video. In the video on anonymous classes, in the previous section, I replaced an anonymous class with a Lambda expression in a method argument using the IntelliJ Code hint tool. I want to do that again here. I'll add some setup code now. I'm going to create a record, and just for fun I'll make that an inner record on the main class, since you already know how to do this if you've been following along with the course in order. If you need a refresher on inner classes, look at the previous section. I'll call this person, and for the fields I'll have two strings, first name and last name. I think I've said this before, but it bears repeating that records are implicitly static when used as an inner class, in the same way enums and interfaces are. What this means is, I can access the record directly using main's class name, if I wanted to create instances of it, from outside this class. Next I want to include a simpler string representation, so I'll press enter between the curly braces and add a toString method. I'll change return null to return the first and last name with a space between them. I want to create a list of these person records in my main method. I'll set up a list variable called people, assigning that a new array list. I'm going to pass it a list of person records, so I'll use the helper method on the arrays class as list to do that. I'll create new records for some of the Peanuts characters. I'll add Lucy, whose last name is Van Pelt, Sally Brown, who we know is Charlie Brown's little sister, Linus Van Pelt, Peppermint Patty, and finally Charlie Brown. I purposely used main.person for Lucy's record just to demonstrate that I could use the class qualifier to create a new person, because person is really a static, nested class of main. This isn't required inside this class, so for the rest of the records, I simply use the unqualified person class. Now I want to create a custom comparator. I'll do this first with an anonymous class. I'm using var as the type for simplicity and assigning it to a new comparator of type person. I will generate the compare method. I'll replace that code with code to compare people by their last names. Compare to will work nicely. Next I'll execute sort on my people list, passing it this anonymous instance of the comparator interface. Then I'll print my people list out. I'll run that to review what we have. You can see my list of Peanuts characters printed out, sorted by their last names, with Sally Brown listed first. Because I only used last name to sort, any person records that have the same last name will still be ordered by insertion order, so that's why Sally comes before Charlie Brown in this case. Next, instead of assigning an anonymous class to a variable, I'll create and use this anonymous class directly in the method argument. First, I'll copy most of the anonymous class statement from after the assignment operator, the equal sign there, and before the final semicolon. I'm going to paste that in place of the comparator last name variable in the call to the people.sort method. I can run it this way, and it works just as before. But notice that IntelliJ has grayed out new comparator, etc. when I use it in the method argument. If I hover over that, I can see I can replace that with a Lambda expression, so I'll do that. That looks interesting. Let's review this expression to make sense of it. On this slide, the syntax of this Lambda expression is on the left below. This was passed directly as a method argument for a parameter type that was a comparator. The comparator's abstract method, compare, is shown here on the right side. The Lambda expression parameters are determined by the associated interfaces method, the functional method. More on the functional method shortly. In the case of a comparator and its compare method, there are two arguments. This is why we get O1 and O2 in parentheses in the generated Lambda expression. These arguments can be used in the expression, which is on the right of the arrow token, as you can see here. Technically, arrow, rather than arrow token, is the official term used by Oracle when using it in a Lambda expression, so I'll use that moving forward. A Lambda expression consists of a formal parameter list, usually, but not always declared in parentheses, the arrow, and either an expression or a code block after the arrow. Because Lambda expressions are usually simple expressions, it's more common to see them written as shown on this slide, which doesn't use a code block or opening and closing curly braces. In other words, the expression should return a value if the associated interface's method returns a value. In the case of our generated expression, it returns an int, which is the result of the compare method on comparator. Next, I want to look at the anonymous class side by side with the lambda expression. I think it helps with understanding the mechanics of lambdas. Perhaps you are asking, where's the link between the compare method and this lambda expression? It's obvious in the anonymous class because we override the compare method and return the result of that expression. We can see the two parameters and their types and what the return value should be in the anonymous class. It's all spelled out for us there. But the lambda expression has no reference to an enclosing method as far as we can see from this code. How can these mean the same thing? How does Java know what the parameters and return type are, or even the method for that matter? For a lambda expression, the method is inferred by Java. How can Java infer the method to use? Java takes its clue from the reference type in the context of the lambda expression usage. What do I mean by that? Here I show a simplified view, ignoring the generic types of the sort method on list. And here is the call to that method passing the lambda expression. From this, Java can infer that this lambda expression resolves to a comparator type because of the method declaration. This means the lambda expression passed should represent code for a specific method on the comparator interface. But which method? Well, there's only one the lambda expression cares about, and that's the abstract method on comparator. Java requires types which support lambda expressions to be something called a functional interface. A functional interface is an interface that has one and only one abstract method. This is how Java can infer the method to derive the parameters and return type for the lambda expression. You may also see this referred to as SAM, which is short for single abstract method, which is called the functional method. A functional interface is the target type for a lambda expression. Let's explore this further in a bit of code. Did you notice that even after I changed that last bit to a lambda expression, IntelliJ has again grayed that out and has another hint for us. IntelliJ says we can now replace our code with comparator.comparing. I want you to ignore this suggestion until the end of this section of the course for now. It helps to understand first lambda expressions, then method references, then comparators' special convenience methods, which the comparing method is. Don't worry, I'm going to cover all of these topics in order. For now, I want to ignore this hint and leave this code as I currently have it with this lambda expression. Next, I want to create my own local interface that extends comparator. As of JDK 16, this functionality is supported, meaning I can declare an interface right here, a local interface in the method block, local only to this method. I'm going to call this enhanced comparator a generic interface with type T. It's going to extend the comparator interface. And this interface is going to have one abstract method called second level that takes two arguments of type T, the generic type. I'll next use this interface to create a second anonymous class. My variable will be called comparator mixed, and I'll assign it a new anonymous class expression using this enhanced comparator and declaring the type argument to be person. IntelliJ is prompting me that there's an error and the solution is to implement the second level abstract method, so I'll do that. Notice here that IntelliJ has highlighted two methods. Why two, when my local interface only has one? What you shouldn't forget is that interfaces inherit abstract methods. My new interface here inherits the abstract method, compare, that's on the comparator interface. I could have implemented it in enhanced comparator, but I didn't. Remember, you don't have to implement abstract methods when you extend interfaces. This means there are now two abstract methods on the enhanced comparator that concrete classes have to implement if they use this interface. I'll generate those two methods. I'll replace return 0 in the compare method with two statements. First, I'll set up a local variable result, assigning it the result of comparing the last names. And then in my return statement, I'm going to use a ternary operator. If the result of comparing the last names is 0, meaning they have the same last names, I want to execute the second level method. Now I need to implement the second level method, which will compare first names. I'll replace the code so that it returns the comparison of both persons' first names. Okay, so that's my new anonymous comparator. I want to again sort my people list using this variable comparator mixed and print my list out to confirm it worked. Let me run this now. You can see the people sorted by last name, then first name on the second line of output. So now Charlie Brown comes before his sister Sally and Linus is before Lucy. Now let's say I want to turn this anonymous class into a Lambda expression. Well, I can't. This is because it's not technically a functional interface. When I say a functional interface can only have one abstract method, this means only one and includes counting any inherited methods. Java can't determine which abstract method to use for this interface, so it can't be a target type for Lambda expressions. In fact, I can use another Java annotation to confirm this. I'll go to that declaration of the local interface, enhanced comparator, and insert an annotation above it. You may remember that an annotation is just metadata or extra information not used by the executable code. But many IDEs like IntelliJ and some frameworks can use this metadata to do pre-processing or implement compiler checks at functional interface. This particular annotation is used to tell users and the compiler that this interface is supposed to be a functional interface and therefore a target for Lambda expressions. But you can see I've got an error there which says that multiple non-overriding abstract methods were found in enhanced comparator. I only have one abstract method defined here called second level. But the problem is that this local interface extends comparator, so it's inherited the abstract method compare on that one as well. I'll undo that last change and remove that annotation. Because this interface ultimately requires classes to implement two abstract methods, it's not a functional interface. I hope that makes sense and that now you have a pretty good handle on how a Lambda expression works under the covers and why the functional interface is the underlying framework for its use. I'm going to explore Lambda expressions in a lot more detail in the next video, so I'll see you there.